Hey guys, welcome back. We're going to talk about even and odd functions, and they are actually very important. Even functions are functions that are symmetrical with respect to the y-axis. Odd functions are symmetrical with respect to the origin, okay? In this picture, here is the y-axis. Since this can get flipped right around the y-axis and look exactly the same, right? There's a mirror image. This is what we call an even function, okay? This, here's your origin. This flips over the origin, and this is what we call an odd function. So if you are symmetrical with respect to the y-axis, you are even, and if you are symmetrical with respect to the origin odd, okay? Origin odd. Here, this looks fantastic, but the only problem is it's not symmetrical with respect to the y-axis. So this is neither, okay? Just because it looks like we can draw a line doesn't mean that it's going to be even or odd, okay? Here, this is going to be odd because it flips over the origin nicely, right? So this part matches this part matches this part, and so on, okay? Here's a little trick. If all of the exponents are even, then the function is an even function. And if all of the exponents are odd, then the function is an odd function. How easy is that? This here has an even function. This here is an even function because we have an even exponent, and actually this is x to the 0. If you guys recall, anything to the 0 power except for 0 to the 0 is 1. So you can actually just put x to the 0, which is 1. So these are all even. So this is an even function, okay? We're not looking at the numbers in the front. I know 3 is an odd number. We're just looking at the exponents. If all the exponents are even, then it's an even function. If all of the exponents are odd, then it's an odd function. Once again, this will be symmetrical with the y, and this will be with the origin. This is neither because we have an even exponent and an odd, so it's neither, okay? So even, odd, neither. So how do we show if a function is even or odd algebraically? It's actually really simple. All you have to do is plug in a negative x everywhere you see an x. Plug in a negative x, and if it comes back and gives you your original function, then it's even. Or you plug in a negative x, still the same step, and then if it doesn't give you back your original function, take out a negative, and then once you take out a negative, if it gives you back your original function, then it's odd. Otherwise, it's neither. I know that this is an even function because I have an even exponent, so I know this is even, but let me show you how to do it. So you plug in negative everywhere you see an x, and everyone should be putting parentheses every time you plug in something. So I see an x, I'm going to put a negative x and then squared. What's a negative to an even power? What's a negative x times a negative x? What's negative x squared? Positive x squared. So this, after you figure out the squared part, gives you back the original function. So once you get back the original function, it's even. Let's try another one. Everywhere you see an x, you're going to put a negative. Any negative to an even power is positive. Any negative to an even power is positive. So don't worry about the negative, it's just x to the 4th. Don't worry about the negative. It's just negative 2x squared because the negative comes from this 2, and then plus 4. If you take a look at this, it's exactly your original function. So since f of negative x equals f of x, it's even. And if you guys wanted to graph this, you'll see it's symmetrical with the y-axis, okay? This I know will be odd because all my exponents are odd. So I'm going to just plug in negative x again. Okay. And let's see. Negative to an odd power stays negative. So this is like negative x to the 7th. Negative to an odd power stays negative. So it's going to be negative x to the 5th. And then negative, I'm sorry, I should have put a negative there, will be, so 2 times negative 1. So this will be negative 2x to the 7th. This will be negative 5x to the 5th. This will be negative 3x to the 1st. This does not match my original problem. It doesn't match it. Let's see what happens if I factor out a negative. If I factor out a negative, all my signs change. That's what happens when you factor out a negative. Do I get back my original after I factor out a negative? I do. So this is odd. Since when you plugged in the negative x, you get back the negative of the original. Okay? And this here will also be odd. All right, so I hope this video was helpful. You can give this a shot by yourself. This should be odd. And have a great, great day.